I want you to picture a scenario. You spent, say, the last 5 years obsessively building this custom high-performance Ferrari. You've got the perfect engine, you've hired a Formula One driver, you've even built a state-of-the-art track.
Okay.
It's race day. The crowd is cheering. You are ready to go. But then you realize something. You forgot to buy a gas can.
Oh, no.
Not the gas itself. You have gallons of high-octane fuel sitting in a tank 50 feet away. But you are missing the actual metal jug to carry the liquid from the pump to the car. So the Ferrari just sits there, silent.
It's a frustrating image. It sounds like a failure of management or just, terrible planning. But if you look at this stack of industrial reports we've got on the desk today, it is a painfully accurate description of where the U.S. energy sector stands right now.
And that is exactly where the United States finds itself right now in January of 2026. If you scan the headlines, you see this massive nuclear renaissance.
It's everywhere.
We see the Department of Energy dropping a cool $900 million just this month to kickstart advanced nuclear. We've got high-tech centrifuges spinning in Ohio, next-gen reactors on the drawing board. But the entire industry, billions of dollars of investment, is being strangled by something incredibly mundane, a metal cylinder.
It sounds almost, ridiculous when you say it out loud like that.
It does, a metal tube.
But yes, today we are unpacking why the U.S. HALEU supply chain is paralyzed.
And HALEU, just to remind everyone, is High-Assay Low-Enriched Uranium, the stuff these new reactors need to work.
Exactly. And the paralysis isn't from, some complex physics problem or environmental protests or even a lack of funding.
Not with $900 million on the table.
It is because we literally do not have the certified shipping containers to move the fuel from point A to point B.
This is the deep dive. Our mission today is to look past the press releases and figure out why the machinery is ready, but the fuel isn't moving. We've combed through reports from PowerMag, World Nuclear News, NRC filings, and some very sobering industrial supply chain analyses that just dropped.
And what we found isn't really a story about nuclear power. It's a story about globalization, lost industrial capacity, and a very specific, very boring metal tube called a Type B cylinder.
So let's start with the immediate situation. It's January 2026. The Department of Energy has just awarded Centrus Energy that $900 million. This is supposed to be the green light.
This is the big moment. Centrus is the main player here, out in Piketon, Ohio. They're supposed to be producing this HALEU fuel that everyone says is the silver bullet for clean energy.
And they are producing it.
They are, technically. They have the centrifuges, they have the contract. But if you look at the fine print of their production target, there's a huge discrepancy. Their Phase 3 output is capped at a tiny 0.6 metric tons of uranium per year.
0.6 metric tons. That sounds negligible. I mean, commercial reactors use tons and tons of fuel.
It is tiny. It's a drop in the bucket compared to what the grid needs. And here's the thing. The reason isn't that the machines can't spin faster. It's that if they produce more, they have nowhere to put it. Centrus has explicitly cited cylinder constraints for missing their targets.
Okay, so explain this to me like I'm 5. I've seen barrels of oil. I've seen nuclear waste drums in movies, the yellow ones with a symbol. Why is this specific cylinder such a bottleneck? Can't they just go to an industrial supplier and buy some high-grade steel drums?
I wouldn't recommend that. See, this is where the chemistry meets the bureaucracy. Most nuclear plants today run on HALEU low-enriched uranium.
Okay.
That's enriched to under 5% uranium-235. For that, you can use standard cylinders, type 30B or 30C. They're common. We have thousands of them.
But this new fuel isn't standard.
Correct. HALEU is enriched between 5% and 20%. It's much more potent. The physics actually changes. If you put HALEU into a standard barrel, you risk something called a criticality accident.
Criticality meaning what exactly? Like a meltdown?
Not quite a meltdown, but an uncontrolled chain reaction. Because the enrichment is higher, if the container's geometry is wrong or if water gets in, you could trigger a reaction inside the barrel.
So, heat, radiation.
Massive radiation spikes, heat, potentially an explosion. It's not just not good, it's catastrophic. So the Nuclear Regulatory Commission, the NRC, requires these special Type B cylinders.
Okay.
And they're certified under a really strict regulation called 10 CFR 71. They have to withstand insane accidents, fire, drops, immersion in deep water without leaking a single atom.
So it's a super shielded, crash-proof container. That makes sense.
Oh.
But surely we have some of these lying around. The U.S. has been in nuclear power for 70 years.
We do have some, but they're mostly legacy models from decades ago, the 5B or 8A models. And here's the kicker. They're small. They were designed for lab samples, not for commercial power plants.
How small are we talking?
They only hold about 115 to 200 kilograms of fuel.
That's nothing. If you need tons of this stuff, you'd need hundreds of those containers.
Thousands, eventually. And yeah, there are new designs being tested, like the DN30X, which can hold over 1,000 kilograms. But those are unproven at scale. They're not ready for mass deployment.
So Centrus is trying to run a billion-dollar factory, but they have to load the product out in the equivalent of, what, thimbles?
That's a fair analogy. It really is the Ferrari with no gas can. And because the product can't leave the building, the centrifuges have to slow down. You can't just keep enriching gas if you have nowhere to put it.
So, okay, we have a shortage, but this is America. When there's a shortage of something valuable, the market usually steps in. Someone builds a factory. Why isn't that happening? Where are these cylinders supposed to come from?
That brings us to the why, and this is where the story shifts from a logistics headache to a full-blown geopolitical crisis. We looked at the numbers, and it turns out the United States has zero commercial-scale manufacturing for these cylinders.
Zero. We don't make them at all.
Zero. We stopped in the 1990s. We offshored it because, it was cheaper, and we didn't think it was strategic. The entire market is controlled by Europe.
Who in Europe?
Specifically, a French company called Orano and a consortium called Urenco. Between them, they control about 90% of the global supply.
So we are dependent on France. That doesn't sound too catastrophic on the surface. I mean, they're a NATO ally.
Usually it wouldn't be, but did you happen to read the analysis coming out of the Davos summit last week?
I saw headlines about tension, but I didn't connect it to nuclear fuel cylinders.
It's directly connected. According to these reports, the nuclear cooperation talks between the U.S. and France they've effectively broken down. We are seeing a rise in what experts are calling uranium nationalism.
Uranium nationalism?
Yeah. France is looking at its own energy needs. They have this huge Astrid fast reactor program, and they're focused on EU security first.
So they're hoarding the cylinders for themselves.
Allocating strategically is the polite term. Orano supplies something like 60% of the cylinders Centrus uses. With these new trade tensions, the U.S. allocation could be slashed by 30 to 50%.
Ouch. So precisely when we need to ramp up, when the DOE just dropped $900 million, our main supplier is prioritizing their own backyard.
And it gets worse. Even if they wanted to sell them to us, the logistics right now are a complete nightmare.
You're talking about shipping.
Exactly. We're seeing a delay acceleration forecast in the supply chain data. Lead times for ordering a new cylinder used to be 12 to 18 months. Now, it's jumping to 24 months or more.
And on top of that, the Red Sea.
Yep. The disruptions there are adding another 2 to 3 months to shipping times.
I read something in one of the reports about air freight. Are they actually considering flying these heavy metal tubes on planes? That sounds insanely expensive.
They are. It just shows the level of desperation. To bypass the shipping bans and the delays, companies are looking at air freight, which costs 10 times as much.
It just destroys the economics of the fuel.
Completely. You're burning money just to move it.
So let's put this on a timeline. The big goal was to have commercial HALEU by 2029, right?
That target is slipping, and it's slipping fast. With these cylinder shortages and the trade fallout, analysts are now saying 2029 is likely pushed to 2033 or later.
Wow.
And the whole idea of U.S. autonomy being able to fuel our own reactors without foreign help, that is starting to look like a 2040-plus reality.
2040. That's discouraging. But it leads me to the obvious question. The question I think every listener is screaming at their device right now.
Right.
We just gave Centrus $900 million. Why don't we just take some of that money and build a cylinder factory in Ohio?
Yeah.
We used to be the steel capital of the world. Why is this so hard?
This is where we have to go deeper. This is what we're calling the rusted link theory. It's really the most profound insight from the industrial analysis we reviewed.
Huh?
It's not just about building a building and calling it a factory.
Okay.
It's about the fact that the U.S. has lost the Tier 2 and Tier 3 industrial base that you need to do this.
Define Tier 2 and Tier 3 for us. I'm guessing Tier 1 is the big guys like Centrus?
Exactly. Tier 1 is the final assembler. Tier 2 and 3 are the suppliers who make the parts that make the machine work. We aren't just missing the factory, we're missing 3 entire layers of the supply chain underneath it.
Okay, lay them out for me. What are the 3 layers we're missing?
Layer 1, raw materials. These cylinders aren't made of standard steel. They use proprietary nickel alloys that have to withstand high radiation and corrosion for decades. The U.S., we don't really make this metal anymore. We rely on specialty mills in Japan, France, and Sweden.
Can't we just open a mill? or retool an existing one? Just tell a steel plant, hey, make this alloy instead.
You'd think so. But qualifying a new domestic mill to produce nuclear-grade alloys takes 3 to 5 years. You have to prove that every single inch of that metal is perfect. No domestic steelmaker has tried this in decades because it costs tens of millions just to get certified.
And the market has been too small to justify it.
Exactly. So that's layer 1, the metal.
Okay, what's layer 2?
Components. Specifically the closure systems. We're talking about the valves and seals that keep the uranium inside. These are ultra-high integrity parts. If a valve fails, you have a leak.
And let me guess, we don't make them here.
They're often single-sourced from overseas. Even if you could bend the metal into a tube here, you'd still be waiting on a valve from Europe to finish it.
And layer 3?
This one is maybe the saddest one, honestly. It's the human capital. It's welding.
Welding? Come on, I see welding shops in every industrial park in America. We build skyscrapers, we build bridges, we can't weld a tube.
Not this kind of tube. To build a Type B cylinder, you need an ASME and stamp certification. It's the absolute gold standard for nuclear-grade work. The welding has to be flawless, X-rayed, tested, certified.
And we don't have those welders anymore.
The master welders who did this in the 1970s, they are retired or gone. It's effectively a lost art.
That's incredible.
There are almost no shops left in the U.S. with this specific N-stamp certification because there hasn't been enough work to sustain them. And the few shops that do exist are booked solid with Navy contracts for submarines. They don't have time for commercial cylinders.
So this is what the report's called the qualification trap.
That's the term. It's a perfect market failure loop. You can't certify a cylinder without the special raw materials.
Right.
The steel mills won't make the materials unless you guarantee them a huge order. But the DOE and Centrus won't guarantee an order for cylinders that haven't been certified yet.
It's a standoff. Everyone is waiting for someone else to move first, and meanwhile, nothing happens. The fuel is just stuck.
And money alone doesn't fix this quickly. That's the big misconception. You can throw cash at it, but you can't buy time. You can't buy 30 years of lost institutional knowledge overnight. You can't speed up a 5-year certification process just by paying double.
That is heavy. It really highlights how fragile our high-tech sector is when the sort of low-tech foundation crumbles. But our sources mention something even scarier. A black swan event. We've been talking about making new cylinders, but what about the ones we are using right now?
This is the nightmare scenario that keeps logistics managers up at night. As we said, most of the existing Type B cylinders are legacy models. That means the global fleet is old. Many of these cylinders are 40 or 50 years old.
Metal fatigues. Seals degrade. Nothing lasts forever.
Exactly. Now imagine a scenario where just one valve fails on an old cylinder. Maybe it happens at a port in Rotterdam or on a truck in Virginia. It doesn't even have to be a major radioactive leak, just a failure of integrity, a crack, a bad seal.
What happens then? Do they just patch it up?
Absolutely not. Regulators in this industry are extremely risk-averse, as they should be. If one fails, there is a very high probability that they would ground the entire global fleet for safety review.
The whole fleet. Like when a specific model of airplane has an issue and they ground every single one worldwide.
A total freeze, a total stoppage. And because we have no surge capacity, no extra cylinders, no armies of inspectors ready to go, this wouldn't take weeks. It could take months or even years to inspect thousands of old cylinders.
And during that time?
During that time, global nuclear fuel transport stops, period. Not just our HALEU program. We're talking about fuel for existing reactors, medical isotopes, everything. It would be a massive shock to the global energy grid.
It's incredible. We treat these cylinders like they're just cardboard boxes, just a commodity you buy when you need it. But you're saying they're a strategic vulnerability.
They are a strategic defense item. One analysis compared it to the defense industry, realizing it can't build submarines because it's importing the cranes from an adversary. We've treated the industrial layer, the boring stuff like metallurgy and welding, as if it doesn't matter. But it turns out that's the foundation the whole house is built on.
So to synthesize this, we are spending billions to build the engine, the reactor, and the fuel, the HALEU, but we completely forgot to build the bucket to carry it in.
That is the core of this entire problem. We are focusing on the shiny, high-tech top of the pyramid, while the base is just crumbling away.
So what does this mean for the listener? If you are hearing about these aggressive timelines, clean energy by 2030, energy independence by 2035, what should you think?
You should be skeptical. Those dates, 2029, 2035, they are likely fantasies at this point. The sources suggest that real autonomy, real energy independence, isn't just about successful centrifuge technology. It requires a Manhattan Project for the supply chain.
A Manhattan Project for welding.
For metallurgy, for welding certification, just as much as we need one for nuclear physics. Without that boring industrial base, the high-tech future remains stuck in a warehouse in Ohio.
We're going to wrap it up there. It's a lot to process. The U.S. nuclear renaissance is being held hostage not by a lack of vision, but by a hollowed-out supply chain and a trade spat with France.
It's a powerful reminder that supply chains are physical. You can't download a shipping container.
Here's a final provocative thought for you to carry with you today. We're currently pouring billions of dollars into this energy transition. But until we fix the rusted links in the chain, until we can make our own steel and certify our own welders, are our energy independence goals just a money pit? Are we building a bridge to nowhere because we forgot the bolts?
It's the question that needs to be answered before 2030 rolls around.
Thanks for listening to this deep dive. Keep questioning the headlines, and we will see you on the next one.